Stabilizing the apparatus is an important first step in preparing the aerial device for use. Stabilizing means to broaden the base of the vehicle so that it is less likely to tip over when the aerial device is extended. Although stabilizing is more critical in certain situations than in others, it is recommended that stabilizers be used every time the aerial device is raised from its bed. In this program, you will learn the basics of stabilizing the apparatus. The training objectives are to describe the general function of the hydraulic system that controls the stabilizers, to demonstrate how to engage the power takeoff or PTO system in various types of apparatus, to present how to set the stabilizers on even and uneven terrain, and to show how to achieve maximum stability for tractor-trailer apparatus. In newer aerial apparatus, virtually all stabilizers are hydraulically powered. Oil is the medium used in the hydraulic system for two reasons. First, it does not compress under pressure, and second, it allows force to be transmitted over a relatively large distance with little loss of power. Force is built up in the oil by a hydraulic pump. This pump is powered by the power takeoff system from the vehicle's main engine. The pressure on the oil may be 3,500 pounds per square inch or more. A pinhole leak with this amount of pressure behind it is capable of cutting through human tissue or causing severe burns. Therefore, always use a tool rather than your hands to block even the smallest leak in the hydraulic system. Valves are used to start, stop, regulate, and direct the flow of oil within the system. One valve that is especially important is the selector valve, also known as the transfer or diverter valve. The selector valve is a three-way valve that directs the oil into either the stabilizer controls or into the aerial device controls. By blocking oil flow to the system that is not being used, the selector valve acts as an interlock to keep the stabilizers and aerial device systems from operating at the same time. All apparatus manufacturers provide an auxiliary hydraulic pump to use in the event of a main hydraulic pump failure. This smaller pump is capable of all the motions of the larger pump, but it operates at a slower speed. Because the auxiliary pump is not designed to be used for long periods of time, use it only to bed the aerial device if the main pump fails. The rule of thumb for using the auxiliary pump is to operate it for 1 minute, let it rest for a minute, then operate it again for a minute, and so on until the aerial is bedded. Power for the hydraulic system is provided by the power takeoff or PTO system. Engaging the PTO provides power to the hydraulic pump, which then creates pressure on the oil in the system. The process of engaging the PTO is similar in most apparatus, but there are a few differences. Let's look at engaging the PTO in different types of apparatus. To engage the PTO in an apparatus with an automatic transmission but no fire pump, Step 1, set the parking brake. Step 2, place the transmission selector in a drive gear. Step 3, activate the PTO selector switch. Step 4, place the transmission selector in neutral. If the PTO transfer is complete, you will see the PTO indicator light come on. To disengage the PTO, deactivate the PTO selector switch while the transmission is in neutral. In an apparatus with a manual transmission and no fire pump, the PTO is engaged as follows. Step 1, depress the clutch pedal. Step 2, place the transmission in neutral. Step 3, set the parking brake. Step 4, activate the PTO selector switch. Step 5, release the clutch. Once again, if the PTO transfer is complete, the indicator light will go on. To disengage the PTO, return the engine to idle speed, then depress the clutch pedal, deactivate the PTO switch, and release the clutch pedal slowly. Engaging the PTO in an automatic transmission apparatus with a fire pump includes a few more steps. Engage the PTO using the steps demonstrated for an automatic transmission apparatus. Once the transmission is in neutral and the required air or hydraulic pressure is built up, operate the pump shift control as directed by the pump manufacturer. Place the transmission selector into the appropriate pumping gear. When the shift is complete, you will see the pump control light come on. To disengage the PTO and the fire pump, return the transmission to neutral, deactivate the pump control switch, and deactivate the PTO selector switch. Once the PTO system has been engaged, you can begin the stabilization process. Before actually deploying the stabilizers, there are several quick checks you should make to avoid potential problems. First, be sure that the PTO light is lit before you leave the cab. Second, some manufacturers recommend that you chock the wheels at this time. The manufacturer will specify whether the front or rear wheels should be chocked. Now, walk around the apparatus and make sure that the travel path of the stabilizers is clear. If possible, a second firefighter should be positioned on the opposite side of the apparatus to keep fire personnel and civilians away from the stabilizers. Finally, check the surface that the stabilizers will rest on to ensure that no loose objects will be underneath the foot plates. Once you have completed the preliminary checks, you are ready to operate the selector valve that will provide hydraulic power to the stabilizing system. The operation of the selector valve varies with the manufacturer. If your apparatus has a manual selector control, it will be clearly marked to indicate the position for each operation. The engine speed is automatically regulated to provide enough power for the operation. Let's look at some general principles for stabilizing on both even and uneven terrain. Ideally, you will be stabilizing the apparatus on even terrain. Flat terrain allows for the greatest stability and also the maximum range of safe movement of the aerial device. Generally, there will be one control for each stabilizer. In most cases, you can operate more than one control at a time. There are three basic ways that stabilizers move into position. The first type is a box type that extends out and then down. The second type is a fulcrum that swings down into position. And the third extends straight down from the apparatus. The box type is the most common on newer apparatus. When operating this type of stabilizer, first extend the parallel arm to its maximum travel distance. Once the parallel arms are extended, place the foot plates beneath the stabilizing jacks. Though some manufacturers do not specify that foot plates are needed on level ground, it is recommended that stabilizers be used every time the aerial device is raised from its bed. Now, lower the stabilizing jacks onto the foot plates. On level ground, you may lower either side first. Lower both stabilizers on one side of the vehicle before you lower the other side. Lower the stabilizers until the pressure lifts the truck up slightly on that side. One way to observe this is to check the tires. When the tires no longer bulge at the bottom, the truck is slightly lifted. When all the stabilizers are on the ground, alternate between the sides to raise the vehicle to the working position. Once again, this will vary by manufacturer. In a situation where space is restricted, partial extension of the stabilizers may be possible if approved by the manufacturer. If partial extension is approved, position the apparatus so that the parallel arms on the side that the aerial device will be operating over will be fully extended. Then, extend the arms on the opposite side as far as possible. Fulcrum type or straight down stabilizers are operated in much the same way as the box type stabilizers. The primary difference is that these stabilizers must be deployed in the fully extended position. Also, when you set the foot plates for fulcrum type or straight down stabilizers, you need to extend the legs to within a few inches of the ground before placing the foot plates into position. On some older aerial apparatus, you will find manual stabilizers. Manual stabilizers are similar in operation to the box-type stabilizers described earlier. On midship apparatus with manual stabilizers, the extension arms are stored perpendicular to the ground. To operate the stabilizers, you first remove the pin that locks the extension arm in the stored position. Then lower the arm to the horizontal position and reinsert the locking pin. Position the footplate under the jack and lower the jack onto the plate. Repeat this process for the other side of the apparatus. On tractor-trailer aerials with manual stabilizers, you will find the extension arm beneath the gooseneck portion of the trailer. First, remove the bayonet pins holding the stabilizer in place. Then swing the jack away from the vehicle and pull the extension arm as far as it will go. Allow the jack to hang down to the ground and place the footplate beneath it. Replace the locking pins and then operate the jack as described for midship aerials. In some situations, you will need to position the aerial apparatus on uneven terrain. When this is necessary, it is important to make the apparatus as stable as possible. Keep in mind that uneven terrain will always limit your operation somewhat, because maximum stability is only possible on flat, even ground. There are two ways that the truck can be uneven: laterally, or side to side, and longitudinally, or end to end. Of the two ways, it is easier to correct for lateral unevenness. You can stabilize the truck on an uneven lateral grade of up to 5 or 6%. Most manufacturers of aerial devices recommend that you lower the stabilizers on the high side of the vehicle first. Lower them only to the point that they contact the ground. Then lower the stabilizers on the low side of the truck until they raise the low side to be even with the high side. After the apparatus is stabilized, it is best to operate the aerial device over the high side of the truck. In all cases, consult the manufacturer's recommendations for the maximum extension and loading amounts when operating on uneven terrain. Remember, manufacturers' guidelines vary widely. For example, at least one manufacturer requires you to lower the stabilizers on the low side of the truck first on a laterally uneven grade. Operating on an end-to-end or longitudinal grade is generally more difficult than a side-to-side grade. In this situation, the rungs of the aerial ladder will not be parallel to the ground if the ladder is operated off the side of the truck. When the aerial device is raised and lowered, there will be a twisting force and resulting motion that is very dangerous to personnel working on or around it. When stabilizing on a longitudinal grade, position the apparatus so that it is in direct line with the intended objective of the aerial device. This means that you will operate the aerial directly over the front or the rear of the apparatus. Once again, follow the manufacturer's requirements for operating aerial apparatus on uneven terrain and stay within the loading limits for your aerial device. Whether on even or uneven terrain, always check your outriggers from time to time to see if they need adjusting. Remember that changes can occur in the surface. Water from runoff can cause the ground to become soft, causing the outriggers to sink and become uneven. One way to avoid this situation is to divert the runoff from the truck area. Also, icy conditions, soft soil, or a punched-through paving surface can all cause an outrigger to become unstable. To achieve maximum stability for tractor-trailer apparatus, you need to apply one additional principle of stabilization. Because stabilization is increased by widening the base of support, you can dramatically increase the stability base of a tractor-trailer vehicle by parking the apparatus at an angle. You can maintain maximum stability when you place the angle of the tractor at 60 degrees from the center line of the trailer. Use all available stabilizers and operate the aerial device over the outside of the angle. Angles of more or less than 60 degrees provide less stability. You must keep the angle at less than 90 degrees, however, as a greater angle creates instability and can cause damage to the truck. One way to put the apparatus into the desired angle position is to stop so that the turntable is right next to the intended objective. Then cut the wheels sharply toward the center of the street. This will bring the truck slightly forward. The tiller wheels should be cut sharply toward the building as the truck backs up a little. When the desired angle is achieved, apply all of the brakes and proceed with deploying the stabilizers. This program has presented basic principles for stabilizing aerial apparatus. We have shown you the basic function of the hydraulic system that controls the stabilizers. We have presented a demonstration of how to engage the PTO system in various types of apparatus. We have shown how to set the stabilizers on even and uneven terrain. And we have described how to achieve maximum stability for tractor-trailer apparatus. Stability of the apparatus is one of the most critical aspects of aerial operations. An unstable situation can create at best a loss of crucial time in rescue and firefighting operations. At worst, it can mean disaster. Learn and practice the principles of stabilization. The people on the ladder are depending on you.